then I'm going to do number 5 also because number 5 is a little bit different. It has a non-standard width parabola. So for the red one, it's just, or I'm sorry, for the blue one, it's just as easy as the others. The difference being the blue opens down instead of up. The red one's different because it's narrow. Okay, so let's do the red one first. Here it is. Okay, do my work in red. So remember, we're going to write an equation in the form y equals a x minus h squared plus k. And so for h, the red one is at negative 0.5. And y is at negative 0.5 also. So we're going to say h is negative 0.5 and k is negative 0.5. So h is going to be minus negative 0.5, so it's plus 0.5, and k is just going to be minus 0.5. Okay, so here we're at now. Okay, now what about the a? Well, we know that the a is going to be positive because it opens up. So a is going to be positive. It's going to be positive. But we don't know what the width is, and so it doesn't look like a standard parabola because if we look at it, we can see that if you go from this point and you look at the first point, it doesn't look like it goes over 1 and goes up 1. It looks like it goes up a little bit more. And like it, if you go 2 over, it's definitely going up more than 4. So it's not a standard width parabola. How do we figure that out? Well, we know a few points that are exactly on whole numbers, and so we're going to take one of those points. For example, let's take the point 1 comma 4, because do you see this point here? It's exactly on where lines cross, so it's actually 1 comma 4. We're going to take 1 comma 4 and we're going to put it substitute it in the equation, and then we're going to see what a is going to be equal to, so that we make the parabola exactly cross over 1 comma 4. So we're going to take this. We have our equation, except we just don't know what a is. So we're going to leave a unknown, and we're going to put in x is going to become 1, and y is going to become 4. Just here. We got these numbers from here because we want the parabola to go through these numbers. We know that the parabola is going to go through this vertex because we made it go through that vertex. Now we're figuring out how we get it through 1 comma 4. So we're going to put 1 in for x, 4 in for y. And then we end up with 4 equals 2.25. If you take 1 plus 0.5 and you square it, you're going to get 2.25. A minus 0.5. And then, so how do we solve for a? We're going to add 0.5 to both sides. We get 4.5 on the left side. On the right side, we get rid of negative 0.5 by adding 0.5. And we're left with 2.25a equals 4.5. And then if we divide both sides by 2.25, we get a equals 4.5 divided by 2.25, and the answer is a equals 2. Okay, so the answer is that the a value here is going to be 2. Okay, now what about the blue one here? Well, the blue one here is just pretty much as easy as the first one. It's just the only difference is that the width, or it opens down instead. So, you do the same thing for the first part. You're going to put in the vertex values in for here. So the vertex is at 0, comma, what is this? 1, 2, 3. 0, comma 3. So the h value is going to be 0, and the k value is going to be 3. And, the a values here, I forgot. Most important. So we're left with ax squared plus 3. Okay? And now we say, okay, what's the a value? Well, we can see that the width of the parabola is standard because, like, when you check to see, well, okay, if I go 1 over, does it go 1 down? Yeah. If I go 2 over, does it go 4 down? Yeah, it does. So it's a standard width parabola. It's just like, okay, but like how, in which direction does it open? It opens down. Well, if you remember, standard width parabola is 1. If it opens down, it's negative 1. So basically we have negative 1 times x squared plus 3. So we have negative x squared plus 3. would be for the blue one.